discuss about my part. The global demand for 3D printing. The global 3D printing market size was valued as US 13.78 billion in 2020 and expected to the expand at a compound annual growth rate of CAGR. So the demand of 3D printing is expected to trigger more in the coming years. The traditional supply chain of 3D printing is here. 3D. Next slide. Advantage of 3D printing: rapid production of the prototypes, reduction of material waste, which can save the cost of the production, no storage cost, ability to customize product, improve the safety, efficacy, and the accessibility of medicine, broad application, flexibility in product development. Limitation of 3D printing. Here is some limitation of 3D printing. High machinery costs, unsuitable to very large product, limitation of raw materials, cost of printers, components do have enough strength, printers are not fast enough, very little R&D is done in 3D printing. Though the 3D has future on a mass scale, it still needs more research and innovation to combat its negative impacts. Next topic is lipolization. Lipolization is maybe defined as a stabilizing process in which a substance is fast frozen and then the quality of the solvent is reduced fast by sublimation, and then the desorption to value that will no longer support biological activity or chemical reaction. So now that is my part. Now I'm coming to my next group member. Thank you, everyone.
My honorable teacher and my classmate, Assalamu alaikum. Myself, Tasnia Alom, class roll 13, exam roll 443. Our presentation topic is 3D printing and lyophilization. Now I am discussing about principle of lyophilization. Lyophilization is carried out using a simple principle of sublimation. Lyophilization is performed at temperature and pressure conditions below the triple point to enable sublimation of ice. The process is performed at low temperature and pressure by applying vacuum. Next slide. Components of lyophilizer. Main components of lyophilizer are refrigerator system, vacuum system, control system, product chamber, and condensation. Refrigerator system. The product to be dried is either frozen before into the dryer or frozen while on the shelves. Compressors or sometimes liquid nitrogen supplies the cooling energy. Second is vacuum. To remove solvent in a reasonable time, vacuum must be applied during the drying process. The vacuum level required will be typically in the range of 50 to 100 microbar. Control system. Control may be inertial or usually fully automatic for production machines. The control elements required are as mentioned above: shelf temperature, pressure, and time. Product chamber. The chamber contains shelf for processing product. The chamber can also fit with a stoppering system. The door locking arrangement by a electric motor. Process condenser. The process condenser is sometimes referred as just the condenser or the cold trap. It is designed to trap the solvent, which is usually water during the drying process. Next slide. Stage of lyophilization. Stages involved in lyophilization processes are freezing stage, primary drying stage, secondary drying stage, and packaging. Next slide. Freezing. Freezing is the product solution to a temperature below its electric temperature. low temperature, and low atmospheric pressure. Formation of ice crystals occurs. The rate of ice crystallization defines the freezing process and efficiency of primary dyeing. Primary dyeing. Next slide. Primary drying. Heat is introduced from shelf to the product undergrated, controlled by electrical resistance coils. The temperature and pressure should be below the triple point of water. The driving force is vapor pressure differences between the evaporating surface and the condenser. Secondary drying. The temperature is raised to 50 to 60 degrees Celsius and vacuum is lowered about 50 millimeter mercury. Bound water is removed. Rate of drying is low. Packing. After drying, the vacuum is replaced by filtered dry air or nitrogen to establish atmospheric pressure. Ampoules are sealed by either tip sealing or pool sealing method. Vials and bottles are sealed with rubber closure and aluminum caps. Thank you, everyone. Now I want to invite my next group member, Muhammad Asafullah.
Assalamu alaikum, everyone. Good morning to my honorable teacher and my group members, and along with our classmates. Now, I want to talk about the lyophilized products in Bangladesh in pharmaceuticals. In Bangladesh, Incepta is the first manufacturer of lyophilized products. Some lyophilized products manufactured by the Incepta include streptokinase, pantoprazole, vecurium, multivitamin, acyclovir. Besides Incepta, there are many some companies like Beximco, Aristopharma, Beacon, Escape, etc. Pharmaceuticals are also manufacturing various types of lyophilized products recently. Next slide, please. There are some advantages of lyophilization. The advantages are removal of water at low temperature, thermolabile materials can be dried, compatible with specific operation, more precise field weight control, sterility can be maintained. The reconstitution is easy. Next, please. Though there are some advantage of lyophilization, here are some disadvantages too. Many biological molecules are damaged by the stress associated with the freezing, freeze dry, or both. The product is prone to oxidation due to high porosity and large surface area. Therefore, the product should be packed in the vacuum or using inert gas or in a container in impervious to gases. Cost may be an issue depending on the product. It's a long-term process. Next, please. Here, some applications of lyophilization in pharmaceuticals and biotechnology to increase the shelf life of products such as the vaccines and other injectables. In food industry, to produce essence agent to preserve food. Next, please. In technical industries, in chemical synthesis, formation of stable products, and others, flora and fauna preservation, recovery of water damaged books and documents. Lyophilization is very important in pharmaceutical sectors and in our life. So many products are prepared with lyophilization products. Some injectable products and the vaccines are very important, and it is vaccines are very need due to COVID situation. But still, the scientists are finding searching of vaccines. And thank you, honorable teacher, and thank you, everyone. If any question, please feel free to ask.
Group C, thank you for your nice presentation. Now, if you have any question, you can ask. Hello.
No, sir. Question.
No question. Okay, I have one question. What is the reconstitution mean?
May I answer, sir, please?
Yeah.
The reconstitution process is restoring something to do its original state by adding water to it. In lyophilization product, the water is dried by freeze drying, and the product will be reconstituted after adding water.
And why do we need that?
Sir,
Yes. Why we need to do reconstitution? Hello. Can anybody tell me?
স্যার এটা হচ্ছে বিভিন্ন ড্রাই যে ইনগ্রেডিয়েন্ট গুলো আছে ওগুলাকে স্যার লিকুইড মানে লিকুইডে কনভার্ট
In
করতে হেল্প
English,
করে
Sabrina, please try to speak in English.
স্যার ইট প্রসেস অ্যাডিং টু
Yeah, I understand that, but why do we need that?
so may I answer, please?
Yes.
So the lyophilized products are like vaccines or powder for injection. After adding to this product or lyophilized products, the powder will turn to the solution. That's why we can inject to our intravenous route or intramuscular routes.
Right. Without reconstitution, we cannot inject them, right?
Yes, sir.
Yes. Thank you.
Welcome, sir.
So now I would like to request group D to start the presentation.
Assalamu alaikum, sir. Sir, can you hear me?
Yes. you can hear.
Yes, sir. Assalamu alaikum, sir. So thank you very much for giving us this opportunity to discuss about these two very important topic nowadays in medical sector is 3D printing in medical sector and freeze drying. In this group, my group members are myself, Mohammad Khairul Alam Ishad, Afra Anom, Brishti Akhtar, Iqbal Hussain, Shopan Hussain. First of all, I would like to invite Afra Anom to continue the presentation.
Thanks, Khairul Alam Ishad, to give me the opportunity to continue our presentation. Assalamu alaikum. My name is Afranam, class roll 16, exam roll 446. Now I am starting our presentation. Here the content. Freeze drying introduction. First, please, first slide, please. First of all, what is 3D printing? Three-dimensional printing is an additive manufacturing process that creates a physical object. From a digital design, the process works by laying down thin layers of material in the form of liquid or powdered plastic, metal, or cement, and then pushing the layers together. Here a few examples: consumer products like eyewear, footwear, design, furniture, etc. Architecture, scale models, maquetters, constructing fossils, movie props, dental products, industrial products, etc. Next slide, please. History of printing. In 1984, Charles Hull invented stereolithography. In 1996, Dr. Gabor Forges observed that cells stick together during embryonic development. In 2000, urinary bladder augmentation using a synthetic scaffold sealed with the patient patent owned cells. In 2003, injected printing to be modified by Thomas Boulder. And 2009, Organovo creates the Novogen MMX bioprinting printer using Porges technology. In 2010, Organovo prints the first human blood vessel without the use of scaffold. In 2011, Organovo develops 3D bioprinted disguised model made from human cell. Next slide, please. How 3D printing works. Here, the process of 3D printing. Now we discuss it using the picture. 3D printing process. At first, design model using computer. That's known modeling. And next is printing. Then the printer should be ready by printer material, and then it printed by the design. And at least it should be dried sometimes or not. And printing process should be occur using a thin layer by layer, and this process to be continued till optimum model get ready. And this is term is finishing. And next slide, please. Next slide, please. Challenges in 3D printing industry. Here 4 challenges we see. High cost of manufacturing, a lack of awareness, still very nascent industry, lack of raw materials. And next slide, please. Types of 3D printing. The 3 types of most commonly used 3D printer technology in medical applications are selective laser sintering, thermal injected printing, fused deposition modeling. What kind of printer should be used? That depends finished product. Now, that's all of my part. Now I want to call Carola Mishad again to explain our next presentation topic. Thank you, everyone.
Thank you, Afranam. This is Carola Mishad, class rule 17. So I'm going to discuss about the 3D printing in pharmaceuticals. A ZipDose is a 3D printer that creates pills by printing out a thin layer of medicine in powder form, which layer of water-based binder spread between each of the powder layer. The result is a tablet that can dissolve with a sip of water in less than 5 seconds. In this 2 picture, you can see a common pill and a pill that printed by 3D printer. That printed by 3D printer is dissolved only 3.63 seconds. That is a huge improvement. So how does it works? How we can make this type of products? This is very much the same as we print the other things. It makes the one layer and then the another layer and then the another layer. But for the previous pill, it printed two layer so that it melted very fast. The process to 3D print a drug on affordable devices could be eventually led to cheaper medication. So here is some examples of 3D printed drugs. Now a very important topic is 3D bioprinting. So the most latest technology of biofabrication of living structure using tissue engineering is bioprinting. Bioprinting is defined as the construction of tissues constructs using a set of technique that transfer biologically important material onto a substrate with computer-aided specialized 3D printers. So what we need to print bioprinting? We need 2 things. One is cell and another is hydrogel. So cell is known as bioink, and hydrogel is known as biopaper. With these 2 things, we can print bioprinted tissues or organ. This printing process is also similar, but here we use 2 nozzles. One nozzle for hydrogel and another nozzle is for bioink. but the process, as I said, the process is same. In this process, it print the one layer, and then another layer, and then another layer, and after all, we can find a full structure of our desired product. So currently progress of bioprinting. We currently a lot of things are making with this bioprinter, such as ear, kidney, blood vessel. We can print human ear within 50 minutes from rat tail. We can also print skin grafts. We can print bones within a day. Here you can see some surgical models that we can print with the 3D printer. Also some models, prosthetic finger, and 3D printed blood vessel lined tissue, a 3D bone implant, ear cartilage, medical devices, synthetic skins. So bioprinting broadcast. Recently we can print skin, we can print bones, we can we can replace tissues, we can print replace organs. After 5 to 10 years, specific organ tissue replacement for important organs like a heart and kidney, personalized replacement of 3D printed joint with custom fit, life-saving 3D printed organ replacement will be happen. And after 10 to 15 years, replacement of 3D printed organs at affordable price. Liver, kidney replacement companies reach maturity. 3D printed replacement for all body organs will be available. So future of 3D printing in India. My previous team said the global share of this thing, and we're going to share the Indian value. So according to research conducted by 6W Research in India, 2014 to 2019, it is grown almost 20%, and it is almost 79 million in 2021. Indian 3D printing platform Think 3D has announced it will be established a 6 million 3D printed factory in Andhra Pradesh in India. The 6 million factory is expected to enable India's medical device market to become more independent, reducing total foreign import from 75% to 10%. This is a huge improvement for a country like India. This was my part, and now I would like to invite Brishti Akhtar to continue the presentation. Thank you.
Assalamu alaikum. My class roll is 18, exam roll 448. My topic is freeze drying. Freeze drying is also called as lyophilization. It is a process in which material is freeze, then high pressure vacuum is applied to sublimate the water in the form of vapor. Coffee was the first freeze-dried food products to be produced, but now vegetables, fruits, meats, fish, dairy products, herbs, and food flavorings can be freeze-dried. Next. Principle based on sublimation, where water passes directly from solid state to the vapor state without passing through the liquid state. Sublimation of water can take place at pressures and temperatures below 4.579 millimeter mercury of and 0.0099 degree Celsius. Materials to be dried is first frozen and the subjected under a high vacuum to heat. Frozen liquid sublimates, leaving only solid dried components. Next, this is phase diagram of water. Next. Steps in freeze drying, pre-treatment, freezing, primary drying, secondary drying, pre-treatment. Method of treating the product prior to freezing include concentrating the product formulation, revision, decreasing a high vapor pressure solvent, or increasing the surface area. Then freezing. The product is frozen. Next. This provides a necessary condition for lower temperature drying. Primary drying. Pressure is lowered and enough heat to supply to the material for the ice to sublime. This phase may be slow because if too much heat is added, the material's structure could be altered. Secondary drying, to remove unfrozen water molecules since the ice was removed in the primary drying phase. In this, the temperature is raised higher than in the primary drying phase to break any physiochemical interactions that have formed between the water molecules and the frozen materials. Thank you. Then I would like to call next group member Iqbal Hossain.
Assalamu alaikum. My name is Iqbal Hossain. My class roll 19. I will discuss about freeze drying equipment. The main component of freeze drying equipment are refrigeration system, vacuum system, control system, product chamber of manifold, condenser. Next. Refrigeration system cools the condenser located inside the freeze dryer. It also cools slips product chamber for the freezing of the product. Vacuum system consists of separate vacuum pump connected to an airtight condenser and attached product chamber. Control system include temperature and pressure sensing ability. Advanced controllers are the programming of a complete receive and monitor freeze drying process. It depends on the application and use. Next. Product chamber are large chamber with system of slabs on which on place the product condenser. It is attract the vapors being sublimate of the product. The sublimate ice accumulated in the condenser. Temperature of the condenser substantially below the temperature of the product. Symmetrical response of the freeze dryer system, drying chamber and refrigeration unit. Drying chamber, the radiant heat source, frozen product trays, and refrigeration unit, vacuum pump, condenser, and ice. Next. Heat and mass transfer. There are three methods of heat transfer: through frozen layer, through dried layer, heating by the microwaves. When heat reaches sublimation point, it rises temperature and water vapor pressure of ice. Vapor then moves through dried food to region of low vapor pressure in drying chamber. Thank you, sir. I would like to invite Shobana sir, please, and now we start this presentation.
Assalamu alaikum, sir. Thank you, sir, to give me opportunity. Thank you, my previous group member. My name is Shobana Hossain and my class roll 20 and exam roll 450. Now I discuss about 3D printing in medical sector freeze drying. My topic is application of advantage and disadvantage of freeze drying. Application: foods and vegetables, beverages, dairy product, meat, fish, spices and herbs, bakery and confectionery. Advantage of freeze drying: Lightweight, which reduce the cost of shipping, require no refrigeration, storage cost are reduced. Physical structure of the foods is not altered. Food retain much of its color, shape, texture, and flavor when is prepared to consumption. When next slide, please. Disadvantage. The biggest disadvantage of freeze drying is its cost. It is extremely costly and may not be cost effective for certain food. Not all foods can be freeze dried. Some may get spoiled when freeze drying. When freeze dried, others may need pre-treatment to retain color or flavor. Additives may be used when freeze drying food. Canning or dehydration is cost efficient compared to freeze drying. Along with the water, other liquid like vinegar can sublimate, leading to spoilage of food or change in taste in some cases. Airtight and moisture control storage is absolutely necessary to ensure that the food doesn't spoil. Even slight exposure to humidity can easily spoil the food. Conclusion of freeze drying: the freeze drying process is expensive, which is restrict its application on wide range in the food industry. New technical solutions are applied to modify the drying process and make it time and cost effective. It is suitable for a high value product with specific biological and phytochemical properties. Thank you, sir.
Okay, thank you, Group D, for
Welcome,
your
sir.
nice presentation. So now it's time for question and answer. If you have any question, you can ask.
Yes, sir.
Do you have any question?
No, sir.
No, the other group member.
No, sir.
I have a question to Group D.
Okay, sir.
Is there any relationship between 3D printing and freeze drying in terms of pharmaceutical application? Do you understand my question?
Yes, sir.
Sorry, sir. Yes.
So is there any kind of relationship? And if so, then where?
So we don't know, sir.
এখন সময় দুপুর
No, no. Okay,
12টা।
the other group member. The other group. So this question is for every group, okay, and we'll discuss it later. And I will expect answer from you. You got my point, right?
Yes, sir.
So today we will end here, and we'll continue the last group in the next day. So I'll call the roll number. Please respond. Roll 1. Roll 2. 3. 4.
Yes, sir.
5. 6.
Yes, sir.
7. 8.
Yes, sir.
9,
Yes, sir.
10,
Yes, sir.
7,
Yes, sir.
12,
Yes, sir.
13,
Yes, sir.
14,
স্যার 14 জব করে তো স্যার মনে হয় সমস্যা
15,
Yes, sir.
16,
Yes, sir.
17,
Yes, sir.
18,
Yes, sir.
19,
Yes, sir.
20,
Yes, sir.
21,
Present, please.
22,
Yes, sir.
23,
Yes, sir.
24.
Sir.
Okay. Take care. Bye.
Assalamu alaikum.
Assalamu alaikum, sir.